But then there's gonna be the guy with the watch we got him.
That guy is gonna.
Extra.
Right now.
He's
gonna get robbed.
And then that kid will get robbed. And it will be
It'll go round
Circle of
and
life.
round. The circle of life.
the tradition of getting robbed from the gold watch. What if we bought them all like Rolexes and just sent them off?
And then I'd sell them all for food
Mr. Elson,
or something else.
Yeah.
I saw a mid-40s man at the gym with a Pearl Jam shirt. I took a picture of him.
Right into the.
There, I think. When did I see him talking about Pearl Jam?
Mhm.
I think it was at the. I was watching the part of the Grizz game. They were talking about famous people from
With Mr.
Missouri.
Norbert.
No. I watched
Oh,
a couple
Faces.
minutes on the phone, and they were talking about Pearl Jam. Jeff Arnett. I think that's his
The
name.
bassist.
Yeah, the bassist.
Yeah. I didn't know if he was from Missoula. I thought it was. I don't know.
I think he lives in Missouri now.
Okay,
I think he's from like Shodo or something. And John Elway lives in Missouri apparently.
Where were you taking?
I was his grandpa was fixing my teeth.
Oh man.
Oh.
You should have told me, Ted. I would have pulled up and worked the morning and shit.
I might need to get a raise.
You might.
Yeah.
Does that mean I will have the pleasure of working on your...
I don't know.
That's kind of weird.
I'm not sure if I
Yeah,
want.
we've all been there and
Hey,
it's all
Tate, did I ever work on your teeth?
Yeah, like
You know,
Why?
raise starting as a line or whatever.
Tate, do you like it or just think it was weird?
that wasn't weird.
We'll see what the orthodontist.
Did I do a good job or are the other people better than me?
I don't know. I
The other
mean,
people
Same.
are way better than me.
you were just putting my bands in, so it wasn't like tedious. I don't know.
Yeah. Positive review.
Positive review.
Okay.
I got yelped on.
We're gonna cruise into 7-1 angle measures.
Did we just skip the entire chapter 6?
No,
Yeah.
not the entire chapter. It's part of. Just part of it. Okay, so 30.5 degrees. You have an initial side and a terminal side, and you make an angle measure table. There's another way you can represent angle measures, and that's with minutes and seconds. Not as commonly used anymore, but it is part of mapping systems. So if you go to use a map or something like that, or GPSs do also have this as an option for minutes and seconds. Yeah.
I was scared so bad.
So when you do this, when you go degrees to minutes to seconds, you think of that as instead of hours, minutes, and seconds, it's just degrees, minutes, and seconds. And we did this in Algebra 2. So if we want to convert this, it's 30 full degrees, and then you're going to have some amount of minutes and seconds, possibly. So again, if you just think of it as 30.5 hours, if you're thinking, okay, 30.5 hours, and I say convert that to hours and minutes, you would say 30 full hours, right? And then how many minutes? 30 minutes, right? And how did you get to 30 minutes? Half of an hour, right? Which is 1/2 times 60. So it'd be the same here, is that you would go 1/2 times 60, or whatever the decimal is. Whoa. That was a coffee explosion. I was erasing it. Yeah. On the mystery bag. That's exciting.
Makes it more mysterious.
It is more mysterious. You can.
Brown's
Mr. Elson, I was-
Hey, good thing we have this.
I was scared so bad. I was like, because I just have 6-2 here. I was like, was there a bunch of homework we had to do over the weekend? Because I like thought you guys did like a lot of chapters.
Okay, and the minutes are represented with the decimal. No, I don't know what to say. I'm glad you're okay too. Alright, so then what if we have 47.324 degrees and I want to convert that? Okay, so you would take this and you'd say 47 full degrees, and then you have 0.324, so you would go 0.324 times 60. A conversion, what does 0.324 times 60 give you?
19.4.
So 19.
19 point what?
4-4.
44 minutes, right? And then if you want to convert minutes, decimal minutes into seconds, you would say I have 47 full degrees, 19 full minutes, and then 0.44 of a minute, which you're going to convert to seconds. So 0.44, or was it exactly 0.44?
Yeah.
You didn't have any training. Okay, so then you would go 0.44 times 60, which gives you
26.4.
26, and then depending on what they want it rounded as, 26.4 seconds. So that's the conversion process from degrees to degrees, minutes, seconds. And the fire crew, for whatever reason, I think it's just all of because like early on they mostly use this with mapping systems. We use the degrees, minutes, decimal. So
What did they?
it was a way to break it up without having long decimals. I don't, but it's not necessary anymore because of the fact that we have like the GPSs and you can just go 47.324 degrees. Not everybody uses this, but most of the information we give is that. And then every once in a while you have to do a conversion. Nobody knows how to do the conversion, but I do.
That's good.
So that's nice. But most of the GPSs you can just convert it automatically. You can just choose whatever you want. So what happens when it's the other direction? Let's say you have 17 degrees, 42 minutes, and 37 seconds. How do you convert that to just degrees decimal?
Divide by 360.
Divide by 60.
Divide something. Just doing a conversion, so you're going to convert seconds and minutes. So it's not just divide by 60, and it's not divide by 360.
Well, you keep the 17.
The 17 is the full degree, right? So 17 point.
You do 42
Uh-huh.
divided by 60
Okay.
plus 30 divided by 3,600.
360.
Not 3.
Is that it?
Not 360. Well, how many seconds are in an hour?
Too many.
How many seconds an hour? 360?
No.
No. How many seconds are in an hour?
3,600.
3,600. Yep. 60 times 60, right? So 3,600. All right, and then that would give you the 17 point right there, whatever that comes out to be. All right. So that is degrees, minutes, seconds. You should know the conversions on that. Another thing that we're going to talk about in here is the arc length. Okay, so arc length, they have a little formula. We've talked about arc length before. Arc length is the measure, it's like a fraction, if you will, of the circumference. So the arc length like this, and it stems from, you can find it, if you have a radius r, a central angle theta. You remember talking about central angles? It simply means it comes from the center. And then arc length is usually represented with the variable s. Okay, so s represents the arc length, and that's just a fraction of the circumference. And so, and it's based off of the central angle, and there's a little formula for that, and that is either like theta is equal to r over s. I'm sorry, s over r, or you can say s is equal to r theta. So if you want to know the arc length, it is equal to the radius times the central angle.
So, the theta is a degree.
Yep, theta, well, degree, radian. Okay, radian measure of the central angle is the number of radian units. So radians, we'll talk about that. Let's talk about in one full revolution on a circle. So that this is again arc length. Arc length. Okay. So if you have a circle and you do one full revolution on that circle here, right? And you go all the way around. Okay, how many degrees do you have in a circle? 360 degrees in one full revolution. Okay, the other thing that we can talk about though, that we don't emphasize a ton in Algebra 2, but we emphasize it on the unit circle, but now we'll emphasize what it is one full revolution, and it comes from the idea that circumference is equal to 2 pi r, okay? So in a full revolution, you can either have 360 degrees, or you can put it in terms of pi. One full revolution is 2 pi. Okay, so 2 pi is simply this is radian measure. When you say anything in terms of pi, that's a radian measure. And then this is a degree measure. So your calculator, you should be able to convert, right? And that would be under mode, whether you're in radian mode or degree mode, okay? So when we talk about conversions, you have to be comfortable going as you go into, like with trigonometry stuff, is that you can say, hey, 360 degrees or 2 pi. They represent the same amount of movement, it's just two different ways to express it. So, usually in mathematics, you end up doing a lot of radians. Outside of mathematics, you're usually talking degrees, right? So if you do a 360 on your skis, nobody says I'm doing a 2 pi. But that would be awesome. Guys, watch me do a 2 pi. That would be awesome. So, if you want to do a conversion, let's say, hey, how do I convert 60 degrees and I want to convert it into radians? Okay, so if you want 60 degrees in terms of radians, there's a conversion. Okay, and that conversion is you would take your 60 degrees and you would multiply it by something over degrees, right, to get rid of the degrees. And so it's the ratio of how many radians are equal to how many degrees. So, yeah.
Pi over 180?
Yeah, so pi over 180, and the reason why we can do that is I was going to write 2 pi over 360. That is the same conversion formula. It's like saying how many minutes are in an hour, how many seconds are in a minute, that same type of conversion, how many degrees are in a radian or in a revolution. But instead of going 2 pi over 360, you can cancel that and say pi over 180. So 180 degrees of semicircle is the same thing as 1 pi. So if you want to convert this, you would just write this as then, okay, this is the same thing as pi over 3. So usually radians will end up with the pi symbol in there. However, if you can convert it to a decimal, when you see a radian measure, or to distinguish, how do I know if it's degrees or radians? If you have like 2.37 as an angle measure, that's what theta is equal to. If you see theta is equal to 2.37, that could be a degree measure. But if you don't see the degree symbol, what is it going to be? Radian measure. Okay, so that's, if you don't see a degree symbol, it's radian measure. If they put a degree symbol, then that is going to be a degree, which would be a very small degree, right? So 2.37 is a radian measure. It represents an angle measure. What is the angle of 2.37 and how would you measure it? Well, let's talk about what our measurements are. Let's actually do a conversion. So we said to convert from degrees to radians, you go your degrees times pi over 180. to do a conversion the other way, let's say I have, pi over 4, and I want to convert that. I want to convert pi over 4 to degrees. So you would take pi over 4 like this, and then you're going to multiply it by your ratio. And and you want to get rid of the pi's, right? So what goes on the bottom? Pi goes on the bottom, degrees go on top. So it'd be 180 over pi. So just the opposite, and then the pi's cancel, 4 goes into 180 45 times, and you would get 45 degrees. So that, that takes care of that. Okay, in this, degrees, that's what we're going to talk about, degrees and radians. So we're comfortable probably looking at a circle with 360 degrees. Let's put some things on here. We would say, okay, this is 0 degrees, and then let's talk about this. This could be 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, and I'll just keep going on this. And then 210 degrees. So I'm just going in terms of 30s is what I'm doing. Whoops, that's 240, not 250, 270 degrees. I'm just going in 30s to split this up to look at it, okay? So you could go any degree measures you want. You could look at 3 degrees, 6 degrees. You could look at splitting up your circle in any amount of degrees. But the reason why we picked the 30 and the 60 and the 90 and so on and so forth, anybody remember the 2 special right triangles that you dealt with in geometry?
30, 60, 90.
30, 60, 90, and a 45, 45, 90, exactly. So we're going to talk about, when we look at the unit circle, we usually break it up in the conversation initially to say, hey, 30, 60, 90s, and then 45, 45, 90s. So in this, this is, if you're going to be looking at degrees, this would be 0, and then also out here, right, 360 degrees. If you're looking at degrees, we're pretty comfortable with, okay, 30, 60, 90, what that means. Like 30 degrees, you could be like, okay, that's about this distance. 60 degrees, it's about that distance. If you said 180 degrees, it's really easy. You just go semicircle, so on and so forth. But if you were to convert this, okay, in terms of radians, what you have is, so this is in terms of degrees, what you have is in terms of radians, you would have 0 radians initially, okay, because if you think about it, you're facing this direction, and you're going to turn some amount of, like over here, you're going to turn 30 degrees, and then 60 degrees, and then just keep rotating yourself around. Here, you're going to start at 0, you haven't moved. We have to transition to, we're not going to talk in terms of how many degrees you turned, you're going to talk in terms of how many radians you turned. So you know that in a full revolution, I've told you, there are 2 pi radians. Okay, so if I did a full circle like this and I turned, I either could say I did 360 or I did what? 2 pi. So if I do a half circle, you know that you went not 180 degrees, but 1 pi. Okay? So a half circle would be 1 pi. And then we can keep breaking it down. A quarter of a circle, 1/2 pi, which we would write as pi over 2, right? And then 3/4 of a circle,
127 or
3/4 pi, 3 pi over.
no, it'd be more.
Not 3/4 pi.
It'd be 1 and 1/2.
3/4 of
3 halves. 3 halves.
2 pi. So 3/2 pi, because it's 3/4 of 2 pi. Okay, so is there a way to then figure out what are, just like I said, 30, 60, 90, okay, what all these measures are? And the answer is yes, there is. Okay, if you're going to look at the same angle measure, so this one was 30 degrees, okay, Well, what is the angle measure here? Well, you could memorize the unit circle like you did in Algebra 2, and you just go, okay, this is 30 degrees, 60, 90, blah, 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 and then you do the radians, and the radians, anybody remember what the first radian was?
1/12.
That would,
5
1 pi over 6.
There was a pi over 12
Pi over 6.
idea in there. It is over 12, but pi over 6, okay? But let's talk about the pi over 12. So what you're representing is this distance here. If you think about it, how many slices of pizza are there in that circle? There are 12, right? So Riley said something out of 12. So this represents one, right here, this represents 1/12 to go from here to here of the entire revolution. What's the revolution?
360.
2 pi, right? So 1/12 of 2 pi. 1/12 of 2 pi is pi over 6. This represents, how much is this? 1/12 plus another 12. How many 12ths is that? 2/12 of what? 2 pi, right? So, Nicholas.
So, if you're like trying to do the unit circle and use free everything, you can just do this
Yeah,
and figure it all out.
yeah.
So, I should have done that last year.
So then,
That's what
so you have 1/12. Now there's an easier way to do it instead of out of 12ths. The same way over here we talked about, remember the conversion was 2 pi over 360, but what did Tate tell us? Instead of 2 pi over 360, he said pi out of 180. So if you think about this, instead of using the 2 pi, let's use the fact that half of the circle is what? Pi. So if you think just in terms of half of a circle, right? How many are there? There's 1, 2, 3, 4, 5. How many? 6, right? So there's 6 in half of the circle. So if you think about that, you're like, how much is this little section equal to then? It's 1/6 of 1 pi. So 1/6 of a pi, right? So you could either, so you could do 1/12 of 2 pi, or you could say 1/6 of 1 pi. And then this is, instead of 2/12 of 2 pi, it's 2/6 of 1 pi. And if you do your math, right, that's 4 out of 12, which is 1/3. This is 2 out of 6, which is 1/3. So this is pi over 3. And then this is 1, 2, 3 sections out of 6. So 3 out of 6 is 1/2, which is 1/2 pi. So 1/6, 2/6, 3/6. We wouldn't write 4/6 pi. What would we reduce it to? 2/3 pi, right? 4/6, 5/6 pi. 5 pi out of 6. 6 pi out of 6. What's this one going to be? 7. Just keep adding another one. 7 pi out of 6. You wouldn't write 8 pi out of 6. What would you reduce it to? 4 pi out of 6. 4 thirds. 9 pi out of 6, but you don't write 9. What do you write it as?
1 and 1/2.
3. 1 and 1/2. 3. And then this is 10 pi out of 6, but you don't write that. What do you write it as?
5 pi over 3.
5 pi over 3. And then 11 pi out of 6. That doesn't reduce. And then 12 pi out of 6 is 2 pi. So you split it into 6 or 12ths. I like the 6 option.
Yeah.
Okay? Then our other one, so that takes care of this concept of 30s, right? 30-degree increments. The other one that we stated earlier is instead of 30, 60, 90s, we dealt with, what is it? 45, 45, 90s, which would be then, we do the,
B into 4.
here, you could either look at your circle in terms of 8ths, right? 1, 2, 3, 4, 5, 6, 7, 8 chunks, or you could look at it in terms of 4ths, right? So 1, 2, 3, 4ths of a pi. So if you think of it that way, this first section is 1/4 of a pi. So 1/4 of a pi you would write as what? Pi over 4. 2/4 of a pi, so 1/4, 2/4, two sections. 2/4 of a pi is pi over 2. 3/4 of a pi is 3 pi over 4. 4/4 of a pi is just pi. 5/4 of a pi. 6/4 of a pi
3 pi over 2.
is simply, what is it? 3 pi over 2. And then 7/4 of a pi. And then 8/4, I keep reading, 8/4 of a pi, which is just simply 2 pi. So again, I would do the 45s, split it into fourths, so that you have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So you just need to remember 6 and fourths, and then just keep adding 1 as you go around the whole circle. Okay, so you'll want to become familiarized with these. The other thing you'll want to become familiarized with is the 4 quadrants and the decimal can be proved very helpful. So in which case, you have your calculator, right? Take, what is pi over 2 in decimal form? And the reason is not every radian we use, right, is going to be in pi format. So you might see radians that are in decimal format, and then you have a pulse of where am I falling in terms of the quadrant. So what does this come out to be? 1.57. Okay, what does pi come out to be? 3.14. And then what does 3 pi over 2 come out to be in terms of decimal format? 4 point what?
7.1.
7.1. And then 2 pi is
6.28.
6.28. And the reason why getting those numbers in general in your head can prove useful is if I said, hey, you're dealing with theta is equal to 2.37, you can say, okay, 2.37 degree mode, you know where that falls quickly, right? 2.37 is a really tiny angle measure. But if it's in radians, 2.37, where does that general angle fall? You don't have to know exactly, but you're like, well, it's greater than 1.57, it's going to be somewhere falling 2.37, somewhere over here. So that helps you at least identify initially where your angle measure is going to fall in terms of the quadrant. And so that's where you, when these numbers floating around in your head, like, can be beneficial for the decimals. If it's something in terms of pi, you can convert it to a decimal, or if you have these ones memorized, which you will for the unit circle, you'll know approximately what that. Tate, you've been patiently waiting.
If to get it from degree to like whole numbers, or not whole numbers, just numbers, you have to turn into a radian first.
Degree to numbers, help me out here. I don't know what that means.
You know how they said, like, over there, he said pi divided by 2 is equal to 1.57. Like, say if you're given to say like 90 degrees, and said turn this into like a number.
90 degrees into a number?
Yeah.
You mean into a radian?
No. Into a radian and then into a number. It's what you just did on the board though.
Yeah.
You said 90 degrees is equal to pi divided by 2, which is equal to 1.57.
Okay.
No,
I'm not sure, I'm missing it. You can keep going, we can keep struggling through.
yeah, is there a way to skip having to turn into radian and just go from degrees of being 90 to 1.57?
Oh, so instead of going 90 degrees times pi over 180,
Yeah.
you could just find out what that decimal is and then multiply it by 90 and you go correct. So, what's pi divided by 180?
2.
You? Pi divided by 180 on the calculator. So at some point, you will have initially, this is the easy one. We'll do like one of these, and then we're gonna transition into something a little bit more challenging. But initially, we will do a unit circle, mid-chapter assessment with no corrections. And probably what we'll do is we'll take 2 of them and then average them. Okay, so give you a chance to do okay on that. And then we'll transition into, eventually with trigonometry, we'll transition into some, where you have to just know them off the top of your head, you know how to circle to look at. So here is a little cheat sheet for you. Okay, don't worry about the backside, the derivatives and integrals. Okay, you don't need to know that stuff, but the front side will give you the unit circle and then help you fill out some of the other stuff as well. We'll be able to fill some of this out through chapter 7. We'll cover a bunch of stuff in that. You don't need to have this memorized by tomorrow. I'll give you a heads up, like, hey, probably next week, sometime Wednesday, Thursday, or Friday, we'll take one of these for the unit circle, but nothing this week. I don't think. We'll wait until we can cover our other sections in there. Okay, so we talked about converting from degrees to radians, and then you can leave your answers in terms of pi, like using like this without taking this as a decimal. Just reduce your degrees. We talked about radians to degrees. Okay. We talked a little bit about arc length, just using the little formulas, which I have erased. We talked about minutes and seconds, conversions. We talked about that. And then coterminal, that's something we need to discuss. And then we discussed our unit circle, where the pi's come from, splitting the circle into 12ths or 6ths, or 8ths or 4ths. We talked about that. And then let's do this, a coterminal. What does coterminal mean? Terminates at the same spot, right? So if you have, and I'm going to use this, if I said this angle measure, now if I start, at my initial ray is usually always along the x-axis when we're looking at an xy plane here. If I go this direction, that direction which I didn't state yet, that's a negative direction. Okay, so that would be negative 30 degrees. If you go clockwise, it's negative. Now, in navigation, you have a compass. That you'll start north and then go from there. That's its own separate deal, which we'll talk about 7-4 or something, 5 maybe. So navigation is different. You're facing north and then going clockwise. Typically, if you're going to go positive, you go along the x-axis and then go counterclockwise. So if you go clockwise, it's a negative degree measure. So coterminal means ends in the same spot. So if they want a positive coterminal angle and a negative coterminal angle with, in this case, negative 30 degrees, what you need to do is figure out your starting point. You always start here, and then you're like, what angle measure do I draw to end up at the exact same spot as negative 30, going in a positive direction? 330 degrees. How did you get that? 360 minus the 30 degrees, right? And then if I want a negative one, you can't say negative 30 because that's the angle measure. You would start here, always start there, and then go, you would have to go all the way around and then all the way back to there. So I went how far? Negative 360, additional negative 30. So how many is that? Negative 390 degrees. Okay, so that's what coterminal means. Okay, you'll have something that talks about, gives us the speed of a revolving gear. Find the number of degrees per minute through which each gear turns. So when you talk about like on your car has a speedometer, right? And then if your car works,
Rick got a new car.
you did.
Yeah, I did.
Oh, cool. What'd you get?
It was it's a Ford Edge.
Ford Edge. Oh, very nice. Is it nice?
Yeah, it is. You got elastic very good care of it.
Nice. My windshield wipers broke this morning. That was a win.
Oh, you drove.
I had to get the Christmas tree here, yeah. And then I bought a new bike, and that's not here yet. My other bike I loaded up on, I can't remember if I drove, the last time I rode it, I think it was Tuesday. And the wheels are so warped that the bike is literally going like this. And I had so much weight on the back, I didn't know if the tire was just gonna collapse. And I was going up the hill back to my house. It's just like,
What warped it?
what warped it? I just time, travel, it's cracked, the wheels cracked, it's got a crack in it.
How many miles did you put on it?
On that bike?
Yeah.
I was bison.
You need to knock down on your
Probably 10,000, at least 10,000 miles.
Oh man.
For how much does it cost to get your like a bike?
I don't buy expensive bikes. That one of the things was only 400. So yeah, 10,000 miles, probably at least. You do the math there. And then like 50 cents per mile. It's like $5,000 in savings.
Although, was it all like work or was some pleasure?
5,000.
Mostly work related on that bike.
Yeah,
As the commuter.
$4,600.
4,000.
Which you then turn into $2.5 billion over 200 years.
Or I contacted Tim Tebow and see if he'd speak to us for 1 minute virtually. You can either have $4,000 or you can listen to Tim Tebow for 1 minute. You choose.
Hello everyone, my name is Tim Tebow. Oh,
You have to keep like inserting cash, keep him talking.
That's word.
Yeah, think about what each word costs.
Sure.
I saw this one of like Jeff Bezos was walking through his factory, one of the Amazon factories, and he's talking with the Amazon worker, and it was calculating Jeff's income during the seconds of talking compared to the worker's income or something. The worker's income is like $1, eventually it's up to like $2 in the conversation, and Bezos is up to like $40,000 in that like 1 minute conversation or something crazy.
Poor Amazon.